Oh, okay, yeah. Well, I think you have seen this picture. Have you? This is about active fault in this region. A lot of them are in Myanmar, and some of them in South China. And this is a tectonic boundary, the subduction zone. Okay? And the color actually shows the slip rate. So you can see the red color is a high slip rate fault. It's a very high potential to have large earthquake. And last Friday, it happened. Okay? This is a seismic activity. So it was a large earthquake. The initial assessment was magnitude 7.7. But I'm not exactly sure what is the real magnitude. We will have to wait for a while until they calculate moment magnitude. But for this large earthquake, the rupture zone is very long, okay? Running to north of Mandalay and down to Naypyidaw. And of course, the strongly shaking area is the area around, close to active fault. You can see this is an intensity map, okay? So I think some of you have been working with to help the people, right? So I think the number of casualties seem to be increasing every day as they learn more. The interesting point is not only this area affected, but also it gives an impact to many other cities. And surprisingly to Bangkok, okay, the capital city of Thailand, which they have many tall buildings damaged by this long distance effect. Of course, there are some impact to Chiang Mai, Chiang Rai, and other northern province and many other cities. Actually, for Thailand, for Bangkok, this is not the first time we experience a distant large earthquake effect. We had when there was an earthquake in Wenchuan in China, very far away. It shook the tall buildings in Bangkok. When we had the Sumatra earthquake, Indonesia, very far from Bangkok, it also shook the tall buildings in Bangkok as well. One of the main reasons is this one, the presence of deep soft soil basin. The soil basin here in Bangkok can amplify the ground motion. Okay? This picture showing the color of soil condition. The green one is hard soil. And then the color change according to this scale. The softest one is a red one. And Bangkok is just happen to be the red zone. And soft and deep soil basin can amplify the ground motion significantly, around 3 to 4 times. Okay? We had evidence before. When there was a small earthquake, moderate one, in Myanmar, it gave an impact to many sites, and this is a record. This is in Bangkok, and this at some other location outside Bangkok basin. When we calculate response spectrum, this is a 5% response spectrum. You can see Bangkok is much higher. Surin, Prachuap, which more or less the same epicentral distance, have much lower spectral acceleration. I think by this time you know what is spectral acceleration. You can use this one. Okay? Another issue is not only amplify the You know, when earthquake happen and it's propagate to far distance, mostly high frequency component will be decay or attenuate fast. Long period component will have a slower attenuation rate. Okay, so when the seismic wave propagate far from the source, the frequency composition change. Okay, high frequency part kind of reduce quickly with the distance, increase in the distance. But the low frequency part, long period part, continue with low rate of attenuation. So when it reached Bangkok, the basin amplify again. And the amplification depends on dynamic property of soil basin. And for this case, soil basin amplify long period part. So you can see the spectrum is more on, is a long period. Similar to midterm exam question. Huh? Remember that? Okay. Which is a typical one will be high and then getting low after 1 second. But this is high at 1 to something. The event on Friday was more than 10 times of this one. Okay. Factorization was much higher than this. So this is a property of Bangkok soil basin. We have a team. I have a research team. I'm working with many of my research partners, more than 20 professors from more than 10 universities in Thailand. So we work on, some of the members are working on this one. So we investigate the soil basin, checking many properties like a depth to the bedrock, the shear wave velocity profile, and we make a model of the basin. We can, make a side response analysis. We can check how much it can amplify the ground motion. So combined with probabilistic seismic hazard assessment, we can estimate the ground motion in Bangkok. Some of the slides are still in Thai. I have no time, no strength left to convert it to English. But I think this day, I think you can translate. I give a copy here. The idea is what we conclude almost 20 years ago is Bangkok is at risk from large distant earthquake. The soil in Bangkok can amplify the ground motion 3 to 4 times. And the amplified ground motion will be long period type. Okay, long duration, long period type. And from seismic hazard assessment, and we conduct hazard de-aggregation analysis. You remember all this? We can identify which scenario contribute most to hazard in Bangkok. So we learned that it could be 7 to 7.5 magnitude earthquake in Kanchanaburi, the western province in Thailand, 200 kilometers from Bangkok. That was one possible scenario. The second possible scenario is magnitude 8 along Sagaing Fault. That one happened last Friday. The third one was is magnitude 8.5 to 9 at subduction zone, the boundary between Indian plate and our plate, in a subduction zone called Arakan subduction zone. Is a large subduction earthquake. All these three are the worst case scenarios. Okay. We are talking about return period of 2,500 years, 1,000 years, that kind of event. So roughly speaking, I do not expect them to happen our lifetime, but we have to prepare for the worst. The chance to have this is a few percent in our lifetime. You remember the concept in seismic design. And we design a structure by allowing them to have some damage. Based on our information, our research data, we were able to convince the authority to issue seismic design regulation. Regulation require all the buildings in Bangkok above 15 meters to be prepared for earthquake. That was in around 18 years ago. They issue seismic design requirement. Is a legal requirement, so everyone have to follow. And then later on, we add the standard. Okay, this is a new version, but the standard was issued more or less at the same time as the legal requirement. And in the standard, this is a seismic resistant design standard. We put the earthquake spectrum, ground motion spectrum. This is a DBE, design basis earthquake spectrum. MC is about 1.5 times higher. Design for this DBE, we expect the building to be able to stand MCE. MCE hit, it should not collapse. Okay, we divide the Bangkok basin into 10 zones. And zone number 5 is the one that have a large number of tall buildings. And zone number 5 spectrum is a kind of long period type spectrum, depending on the depth of the soil, depending on the soil property. Okay. So since that time, Bangkok has been preparing for this one. But of course, during the past many years, people complain that why do we have to do this one? And people believe, some of them do not believe in this impact, many of them. And many of them think that it was not necessary until Friday. Okay, now the attitude changed. They think that why don't we put more? Okay, we should have put more higher requirement. This is a ground motion we record. This is in King Mongkut Institute of Technology in Thonburi side of Bangkok. The ground motion is not so strong. Okay, it's 0.02 G. 0.02 G. That's the ground motion you feel. You felt on Friday. This is in Bangkok Sirikit Convention Center in downtown Bangkok. More or less the same level. It's a long period ground motion. You see the time scale. This is a 50 second. So it's longer than 1 minute. We at Pathum Thani, we felt the ground motion, right? So we compute the response spectrum. These are response spectrum of the ground motion. This is a MCE spectrum. This is a DBE spectrum. This is a natural period. Spectral acceleration. All these spectrum are made for 5% damping. But the real building may have 2% damping, 2.5% damping, or 1% damping. The response may be higher. Okay? And you need to correct for geometry, mass distribution. You know how to do it, right? Okay? But what we can say is, for most buildings in Bangkok, even tall one, they are lower than DBE or MCE. But we may have to work on this one. This is a long period one. But of course, for this long period structure, response will not be only on the first mode. If you have second mode, third mode, but third mode are lower than MCE. Okay? When you compute the response together, you have to consider 1, 2, 3, many modes. Okay? So roughly, everything altogether saying that the ground motion is lower than the setting criteria. So we came to the conclusion that if people, engineers follow the standard properly, analyze by using a proper analysis process, and construct properly, the building should be able to stand against this one. Okay, because this is not even the worst one. But of course, you see already, there are many damage to tall buildings. And that can be explained also that although in seismic design approach, we actually aim at the main structural system. We try to make the building safe, but we normally do not design for non-structural component. And damage you see a lot, the non-structural component, the partition wall, the ceiling, the duct, water pipe system, and many others non-structural components. They are also sensitive to seismic effect. Maybe in the future, we have to take care of this issue because in some countries, especially seismic active area, they are going to change their practice, not only design for structure, but also for non-structural components. Okay? But now you can see the impact. Many people were afraid and still panic, not willing to go back. Or some want to go back, but not allowed to go back to their condominium rooms. Huh? Okay, but I think this gives you the idea of the picture, the overall idea. Sky fall. Okay, the question they have is, will it happen again? If you turn it to the side, this sky fall is actually vertical. Now we move it, put it horizontal. Here, Mandalay. Okay, this is a rupture zone for the past event. Okay, 2010, 1850. This is a time scale. Earthquake happened along this fall, 7.7, 1912. Okay. Then nothing happened between this time, between this part. And then it happened on 28 March. Okay. So you can see this is actually the seismic gap. It happened 113 years ago. But during this time, maybe it accumulates some sufficient strain. This part happened 90 years ago. Okay. So it may have a significant level of tectonic strain. So maybe possible to continue to have a rupture. But again, we do not know when. But it have quite a high tectonic strain already. Okay. But if it go down, then it will hit many other cities. Okay. So this is, but normally when I talk to the news media, I will not discuss this issue. Now this, I think the people need to be calm down. Okay. But you are engineer, so you need to know the information, the fact. Okay. So this is about earthquake event. Do you have any question to ask? Ground motion data. You mean you have a seismic station around Mandalay? Should be a strong motion recorders. The station, normally seismic station, we have seismograph and strong motion accelerograph. Seismograph we go off scale if it's too close to the source. But strong motion accelerograph they are designed to record the strong ground motion. If we can find one or more, that will be a very high valuable information. Can you get one? Nobody replies. Yeah. All these are estimates from ground motion prediction equation. You know, they just estimate from seismograph, they estimate the size, the rupture zone, and they apply attenuation model. Okay. But what I know is also most buildings in that area are not designed for earthquake. Yeah. So, yeah. That's why you can see extensive damage. Okay. They have they do not follow. I sent one of my students to check before earthquake happened. She checked and reported to me that most 90% of people there thought that if earthquake happened, it will just causing slight to moderate damage. None of them know. None of them knew about 1912 event in Mandalay. That was a big surprise. Okay. So earthquake, major event can be forgotten. Okay. So they are not properly prepared for such a large earthquake.
Can you things seen in the India or Bangladesh side? About the side.
I'm not sure, but I think for the ground motion, we have a kind of directivity effect. The rupture go down like this. The strong direction will be around here. Okay. Less stronger direction, much less, it will be on the opposite. So this one will be weak, moderate, strong. We call directivity effect. But normally these directivity effects have not been included yet in normal GMP. Okay.
Yangon is not affected.
Yangon is here? I don't know.
Yangon is too far from.
Yangon have also tall buildings, huh? How tall? It will be nice if you have a ground motion record in Yangon. Do they have? Anyway, I already present what I know. If you have more information, please let me know. Okay, my slide is here. Okay. Liquefaction along. Is severe one? Okay, I think we need to have good collection of videos and all this earthquake impact. It will be quite valuable for later study. Yes.
Liquefaction, something like.
What? Liquefaction?
Maybe I'm not sure. Like
maybe not.
Maybe not.
I'm not exactly sure what it is.
What pressure is come out.
You are about to say something?
The return period is about 2,500 years.
Hmm?
The return period is 2,500 years, a long time span. So normally people will think that it won't happen again in like 50 or 60 years after this one.
Uh,
So you said that 100 years significant, but energy is just accumulating. The return period is quite long, so it won't.
actually, 2,500 year return period is something we trying to convert the meaning of seismic hazard into something easy to understand. It is in fact probability of exceeding some number of about 2% in the exposure period of 50 years. Okay? But still it means that there's a low chance to have such event. Okay? But you already have it. Like in Turkey, they estimate DBE, MCE, and then the earthquake happened. The level exceed DBE, exceed MCE in along the fault in the south of Turkey, much higher than that. So we are saying that event is long return period, but it happened in our lifetime. Okay, so we are not. This is our assessment based on the best available information, but it does not guarantee that it will not exceed the level. Okay.
So, sir, we are seeing the seismic gap is so like I noticed magnitude about 7.3 and 7 happens only after 1 year.
Which one?
Then this one,
This one.
only after 1 year.
And this is, I don't know, one of these is Pakpo, right?
I am worried about that.
I don't know too. But from the history, it has already been 90 years. Oh, almost 95 years already. So this is 113 years from this event to this event. But I don't know, this is already 95 years with no major event in between along this time. No.
My question is in this 1929 and after 1930, it gets only 1 year and can fit earthquake. I'm worried about maybe next year, but do I need to worry about?
Yeah, when you have a rupture like this, sometimes it trigger the next one. Okay, because when you have a rupture, it actually modify the stress strain condition along the same fault in a nearby area. So when this rupture, maybe it trigger the other one. Okay, so we do not really know what is happening around here. No one can predict yet, but there's a potential. We can see amount of strain accumulated, and the slip rate is continuous, 20 millimeter per year. But it's not slip. Two sides are moving with relative 20 millimeter per year, but it's stuck. So strain accumulated, and you have to rupture from time to time and rupture again. Okay.
Excuse me, sir.
Just a minute. Yeah.
What do those terms free and step over mean in the one line picture? Free and step over.
I don't understand what you are saying.
The terms free and step over.
Oh, I'm not exactly sure. I just copied this one from seismologists. There are many details because the Sagaing fault may not be a single line fault. They may have a branching, parallel fault, and so on. Okay, then they have given a lot of names. Those who study the fault. Yes.
Professor, from that response spectrum graph,
Yeah.
the response spectrum from earthquake was exceeding for time period more than 5 seconds, right?
Yeah.
So
This part,
then the
yes.
dB, yes. So does that mean it needs to be revised, the design?
Well, we may
For
have to review this part again after the urgent issues are over. We may have to review the seismic. But normally, if your buildings are 60-story tall, the first mode may exceed MCE, according to this. But your second mode is much lower than MCE. Your third mode is much lower. And your response in total, especially shear, have a contribution from first mode, second mode, third mode, a lot. This is the nature of tall buildings, not just one mode. So when one mode, one location exceeds, doesn't mean everything exceeds. Still, it will have much lower than if you have a spectrum like this. This one is lower, but that one is much higher. You have extremely high second mode, third mode effect. Okay, so this needs more detailed study. Okay.
After the earthquake on Friday, we got an alert from Bangkok government or somewhere that at 2:30 there will be aftershock.
Ah.
How reliable?
No, not reliable. You learn already. There are so many fake news spreading all around. This is happening every time you have earthquake or major disaster.
So administration people all running out because they got it from official channel.
Yeah, you should tell them. Okay. They did not attend my course, so it's okay. Okay.
excuse me, sir.
Yes, yes.
Sir, in Bangkok, one construction building fell all of a sudden, right? So
Oh, yeah.
what was the reason for that?
I don't know. You saw that, huh? A 30-story building under construction collapsed onto the ground. Some say that the first story columns were too slender and it ruptured first, it fell first, leading to the collapse. Some say that the shear wall behind fell and bring down the whole structure. Some say that it's a progressive failure from punching shear of the slab and above and going down. I do not know. But there's already an official investigation team formed already. And I'm one of the members. So I may know later, but I do not know now. Okay? So there will be a detailed investigation to find out. But of course, it's a 30-story, so it should be around here. If they design properly, it should not fail. Okay? Maybe there are something else. Maybe not properly designed, maybe not construction technique is not right. Maybe the material property is bad. I do not know. Okay, that's something to find out because many other buildings of the more or less the same size, they can stand. That's why this one requires proper investigation. Okay. Any more questions? Maybe enough for this side story. So we come back to wind effect. All right.